Okay, so welcome back. Ang pag-uusapan natin ngayon is solids of revolution. So under solids of revolution, we have three topics. The first one is the circular disc method. The second one is the cylindrical shell method. And the third one is the circular washer method. So first ay pag-uusapan natin ang circular disc method. So the solid generated by revolving a plane area about an axis in its plane is called solids of revolution. When the axis of rotation is a part of boundary of the plane area revolved and the solid sliced, the volume element will be in the form of a circular cylindrical disc. So if we are going to consider this, so let's say we have this x and y axis here, and at point A, no, so ito yung ordinate natin dyan, and at point B, this is our ordinate. So this is our A and this is our B. Now, if this is not a straight line per se, yan. So kapag ito, ang figure na to ay pinaikot natin about the x-axis, so we can consider our x-axis as the axis of revolution. So if we are going to imagine ano yung magiging itsura nito kapag itong area natin, no? Kapag itong area na to ay pinaikot natin with respect to the x-axis. So ang mabubuong figure will be this one. No, so if we are going to consider a volume element, no, taking here, no, at the cross section, let's say at this point y here, ito sa point na to, this is our y. At kung kukuha tayo ng volume dyan, ang mabubuo natin dito is a circular disc, no? So sometimes ito ay tinatawag kong piso method. So bakit siya tinatawag na piso method? Kasi mukha siyang piso, no? As you can see, itong nakakulay na figure, kapag yan ay pinahiga ko, no? So, yan, mukha siyang piso. And ito yung volume na to. Ito yung volume element natin, no? To represent the total volume. And if we are going to consider this, if we are going to consider the solid formed by revolving about the x-axis, what we are talking about here is the area bounded by the x-axis. So bounded by the x-axis, and of course our curve, which is the function f of x, and the lines x is equal to a and x is equal to b. So we are talking about this area wherein itong area na to ay pinaikot natin about the x-axis. So kapag ginawa natin yun, ito yung figure na mabubuo natin. Now, as shown in the figure, we can compute the volume by taking the circular cylindrical disc element. As we can see here, if we are going to take this element here, since kung pag-uusapan kasi natin itong piso na ginawa ko kanina, this is the radius, no? And of course, itong thickness na to, that is the differential, no? So in this case, this is the differential in y. Ito lang muna yung pag-uusapan natin. Kung titingnan natin dito, the volume will be the area of the base multiplied by the thickness or the height nitong figure natin na solid. Now, for the area of the base, this is a circle, so meaning yung area ng base natin is pi r square. How about the h? The h here is equal, of course, to the thickness, which is the dy. So if we are going to compute for the volume of this, we have here the pi r squared dy. Now, if we are going to consider this, itong nabuong circular disc na to, we have the differential of the volume is equal to the area of the base multiplied by the thickness. Now, as we can see here, the area of the base is the area of the circle, which is the cross-sectional area. No? At makikita natin dito, since the cross-sectional area is pi r squared and multiplied by the thickness or the height. So with this, we can say that the differential of the volume is equal to pi, and our radius here is equal to the value of y. So we have y squared, and the h is the dx, the thickness, no? So this would be equal to dx. So with this, if we are going to compute for the volume, no, the total volume for this solid, we have here this pi integral of the y square dx. Yes. So what is the limit? Since we are in dx, no, we are in x, so the limit is from a to b. So we have here limit from point A to point B. But if we are going to recall, this y here is also the function of x. So we can also generalize that the volume is just equal to pi we will be having this figure. So we will be having this figure. We are going to take the volume element. No? So dito, we will have this piso. No? Ito yung piso na mabubuo natin. And ang pag-uusapan natin dito is the thickness dy. And of course, this is the radius, which is equal to x. No? So in this case, ito yung x yung kinuha natin. Okay? So, kung babalikan natin yung pinag-usapan natin dito kanina, actually, ito na siya. So, kung babalikan natin yung pinag-usapan natin kanina, we have this volume. So, this volume here is the differential of the volume, wherein yung pinag-uusapan nating volume dito ay itong volume element natin, which is the piso. No? Since this is a circular disc, so we have the differential of volume is equal to pi r squared dy. Now, as we can see here, we have here the volume for this is equal to pi integral of the radius. No? So, radius natin dito is x. So, therefore, we have here x squared dy. Now, what would be the limit? The limit would be from, since we are in y, the limit would be from point C up to point D. So we have here from point C up to point D. In same manner, for our generalization, we can say that the volume for this is just, so the function, since this x here is just equal to the function g of y, so we can say that this is g of y squared dy limit from point C up to point D.